Okay, well, I'm the Chief Geologist for Mawson, and I'm actually going to give one of the lowest tech talks I've given in a long time. I'm responsible for projects across our business, Mawson Gold it's called now, and we're drilling at the moment in Victoria, as well as we have an advanced gold and cobalt project in Finland in the Paleoproterozoic, and we also have some ground here in the Isa block. And I'd just like to follow up on the finish side just for a start, just because of the relevance of that with the Barramundi orogeny here, in that the great oxidation event in the Paleoproterozoic and the subsequent global black shale event is one of the key drivers in the same group of weird mineral or elements that you see all throughout the block here. This whole transition metal, rare earths, phosphates, uranium, all of those things. And it wouldn't surprise me if the breakup of the Kennerland business was actually related to some of the metallurgic or the metallic elements that we see here in the Isa block. So just think back in terms of the remobilisation story to that big, massive event that's responsible for the biggest gold accumulation since the 2.6 Archean event, because it is really globally significant. And at the moment, I suppose the place you could put your head to is the presidents in South Dakota. They're all standing there in the 1.8 or so billion year rocks that are all associated with that global tectonic event. But back to here. So first up, just thanks to the contributors, including the CEI funding for allowing us to drill this project. We started about 7 weeks ago and the hole finished about 3 weeks ago. So you'll understand why the data are somewhat limited. So I will talk about the background to the project and also what we actually found in the drill hole without any assay data, which are currently at the lab. Standard TSX disclaimer for anything I say. We know this, but this is partly a corporate talk as well. Just the significance of the Isa block in the buried part of it should not be cast away there, and it's been mentioned during the day, and we've heard some fantastic ways to distinguish whether or not there might be something large down there, and I look forward to working with people on maybe some of the core that we've got here. So we're down southeast of Cannington, about 483 square kilometres, and we received 200,000 towards this drill hole. Here we are looking out towards the northwest, Cannington. Let me just put the pointer on here. So Cannington up here, and our project area out to the east undercover, and the F11 target sits down here about 50 kilometres or so to the south of Cannington. We have, as people have mentioned before, there are lots of competitors down here to the south, some people with more money or more brains than us drilling in deeper ground. There is the 200 metre depth to basement contour. So we're sitting in between 200 and 500 metres. We originally picked up this ground when we knew that the data from the airborne EM survey was going to be released. Unfortunately, as people would know, that didn't see through the somewhat conductive cover. So we followed up with that and did some ground gravity, and also flew some more magnetics. And we tried the worm story for gravity. I know some geophysicists love this and some geophysicists don't like it. It produces a whole lot of lines that give geologists a way to choose targets, and I'm still not convinced that we've chosen one that's worthwhile, but let's see. You'll all know that we go out here, we look at existing target types and known deposits, and we try and match them up so we can justify our expenditure. Our F11 target here is up in the top left. You'll see a complex magnetic signature and the gravity high over the top. And this target, by the way, was originally described by BHP, and they decided not to drill that before we picked up the ground. So I'm going to do this for a moment because we all do this job built on the shoulders of others. And I'd just like to remember those that have come before us that are no longer with us through various events over the last many years through this project. So I know it's affected a lot of us. So I'd like to acknowledge the contribution of others. Thank you. So the targets, we developed the targets through our magnetics and classified them, ranked them, and eventually chose this F11 target here down within the belt of rocks that he's probably sold his cap group down here to the south. Here's Cannington up here to the north. So happy that we could go there. We justified the funding to the department, and then we got told with about 3 days' notice that the drill rig was available. So we basically ran from Brisbane to the field and got going. Fortunately, we'd just had the approval from the local Aboriginal group. So on a prospect scale, this is what it looks like. The RTP magnetics, regional gravity linears there in the green. Second vertical derivative there, number 2. And then we took some depth slices. And if you go back to Mark Hinman's lithostructural interpretation, there was perhaps a dike or something coming across here as he regarded one of the options for the cause of the magnetics. We did an inversion on the gravity, and then we've made a couple of 3D models, and I will just let this run. So here's the first model. And just take a note of the magnetics in blue and the gravity in yellow, and look at the spacing. So that was the first model that we ran. And with that, this is about 400 metres from the surface down here to the top of the gravity anomaly. And then we made a gravity and magnetic inversion using remnants. And this is what's frightening about geophysics always, in that you see the target, the magnetic target, merge with the gravity target. And it shows you at this depth the role of remnants and how messy it gets with trying to invert these models, especially when you have no idea under 400 metres of cover what you're actually going for and how much remnants will be involved in it. Anyway, we decided to take model number 2 because that looked easier to drill than model number 1 because it was both in the same place. So we got going, and here we go. We blasted through the cover, and our friends at DDH1, and this is the geologist who perhaps hasn't seen too many of these rocks recently and drilled through the Gilbert River Formation and went down into the basement. We could argue that we had a very stable pre-collar and cemented it off and left the sacrificial casing in the hole. So we can go back if we need to. What did we find? Well, some days I like igneous petrology and some days I wish there was none of it. But first up, pretty simple feldspar granitoid. Nothing unusual in this part of the world. Moderately deformed to locally massive, some pegmatitic rocks around. Mafic amphibolites. I went and measured the density, and sure enough, these are about 3.04 against the rest of the rocks at about 2.7 density. So if you go back to the geophysicists as we've had the discussion, there's probably enough density contrast there in the mafic rocks, if there's enough of those to make the gravity target. But we all know the story that if you go to Cannington or somewhere like that and then model the gravity, there's a whole bunch of mafic rocks there as well that likely make the gravity anomaly rather than the mineralisation itself. So the jury's out, but there are quite a lot of iron-rich mafic rocks there, and you get this almost Potosi, if you come from Broken Hill, Potosi-like texture of garnet-bearing amphibolites where they're slightly altered. There's all sorts of signs of Cloncurry fault-like rocks and low temperature alteration here. So there is lots of biotite, sericite, pyrite altered rocks. And I'll show you a couple of the textures that we've gone through. And when I say lots, there's plus 100 metres of this lower temperature alteration here and there, and that nearly always has disseminated pyrite in this variety. So chlorite, cerussite, quartz carbonate, altered rocks. And as we continue down the hole, this is one of my favourite structural geology photos. There's some sort of cataclysite ball in the top right that is chlorite, quartz carbonate, plus probably graphite. It looks like graphite, and we'll know very shortly, but and it certainly smears and stains out like graphite, but we all know how hard ultra fine grained chlorite can look black at times. But there is lots and lots and lots of brittle faulting, quartz carbonate, and graphitic looking shears within these rocks, and lots of pyrite, disseminated pyrite associated with it. So if you're in the gold world, it's sort of nice gold alteration generation sort of space. And let's see when the data comes back from the lab, what else is in these rocks. And when you come out of those rocks, you actually start to see some potassic alteration on either side. So it's basically biotite goes to cerussite and chlorite in the guts, and on both sides there is both oxidizing and alteration, and chlorite plus or minus pyrite. And textures such as this. I don't have all the orientation data plotted up yet, so I'll leave you without the benefit of stereo nets. And then we run into rocks that look a little more familiar to people who drill in this part of the world looking for Cannington type things. Massive quartz pyrrhotite rocks with disseminated chalcopyrite. And there's always the question, and we all know in the Eastern Succession how hard this stuff is. There's pyrrhotite and the amphibolite facies rocks all over the place, and there's disseminated chalcopyrite around. And of course, the questions such as were raised this morning about copper isotopes and things may actually be a good path here to, is it a sweat out of some mafic rock in terms of producing disseminated chalcopyrite, or is it part of some other sort of system? And those are always the questions we face. And being a junior exploration company, facing those questions at minus 600 metres when we have gold sticking out of the ground in Finland is an interesting one. So we will be happy to work with other people to consider those options. There are some, you can hear my Broken Hill world coming out, Semitic looking rocks, so biotite quartz feldspar rocks with disseminated pyrite throughout them, and some retrograde alteration with chlorite shears on the margin. And we're getting down in the hole to around 750 metres at this stage. And lots of late alteration. So I suppose the good thing about when you look at these sorts of rocks is at least there's late alteration in them because that seems to be associated with mineralisation all over the place. We're about, 30 kilometres east of Osborne here as well. And right at the bottom of the hole, just before the end of hole, goes back to relatively pristine looking sillimanite biotite plus or minus garnet schists, and the hole ended around 10 metres below this. You could say, well, how do we go in terms of the magnetics and the magnetic target? I'd say the jury's out. There was nothing really magnetic in these rocks. So perhaps it's not a remnants-caused magnetic anomaly, or perhaps there's just magnetite-bearing amphibolites out to the west. But I would say we've probably intersected the dense target, but I'm not convinced that we've gone to the magnetic target yet. So where do we go next? This is early in the morning, just before rig shut down. So what are we going to do? We need to make a complete structural interpretation. That's up to me. Courtesy of, we're very pleased to have the funding. So we're going to do because it's a CEI funded hole, we're going to do a full suite, the complete package because otherwise, you know, if you do ICP-MS, you don't get useful elements. So we will have a full suite of assay data. I've chosen 30-something samples for petrographic examination, and I'll put all that together and clearly have to write a report. But we will then consider what to do with the rest of our ground and perhaps talk with others about joint venture options, because as we all know, the money can't go everywhere. And I'm going to say that's it. Thank you very much indeed. And I think we're trying to stick to time. So thank you, Helen.
Thank you,
Happy
Nick.
to take any questions.
Fantastic. Looking forward to those assays.
Yeah, so am I.
See what's down there.
Hope there's some gold in there.
Any questions for Nick? There's a question online.
Okay.
This is from Murray Hutton. At those depths and under more than 200 metres of cover, what size deposit in terms of tonnage and grade do you anticipate will be required to make it an economically viable deposit?
I can think of one word. The answer is big. The problem with these targets, you have to hope it's going to be a reasonable size. It clearly has to be underground. Although something like Cannington clearly would work at that depth to go down there. Well, depending on, obviously, the metal price cycle would be an issue. But we were thinking Cannington, IOCG in our targeting. So, and given the anomaly sitting out by itself, half a long strike from Cannington, we thought that it was a worthwhile target. And clearly there's other people who are drilling down in much deeper ground who know more about metal prices and base metals than we do, and they're prepared to drill to 1,000 metres. So I'm happy to take their advice.
Fair enough. Any questions in the room? Hold on, Dan. We need people online can't hear you.
Sorry, the slimonite schist in the bottom of the hole,
Yep.
do you think it's a retrograde alteration product, or what are your thoughts on it?
It doesn't.
And what sort of garnets do you think you're dealing with?
It doesn't look like those beautiful manganiferous garnets or spotty little garnets that you get around Cannington, Pegmont or Broken Hill. And I did look pretty closely and thought about that. I'll be interested in the manganese content of the host, having, spent 30 years thinking about Broken Hill type. I'm pretty keen to look for those signals. So it actually just looked like a normal high-grade peelite, unfortunately.
I just had sorry.
No, go ahead.
This is a sort of slightly tongue-in-cheek question, but I noticed it was I presume the hole was pretty steep, and the foliation was at a pretty high angle to the hole and was oriented. Was that a flat foliation, or was it a steep foliation at the bottom of the hole? In light of our seismic discussion yesterday.
Okay, the foliation, I think, I could go back to the numbers, but I think it's about 70 degrees to the east. So that hole was 70, by then it was about 71 degrees towards 292 or something rather. So it had just started to lift out to the west and north.